Hi everybody, welcome to the mystery of the Saddle Mountain Billboard. I got to admit I'm feeling a little bit silly. It took me, 3.5, 4 hours to make this 7-minute video. So I hope I will get faster at it. And by the way, this is far from the most geeky thing I have ever done, but I did have a good time and I learned a lot, and I learned a lot that I don't have time to tell you about right now, but maybe it'll come up later. So hope you enjoy the show. Okay, here we are in downtown Mattawa, and there are the two antennas on the CenturyLink building. I'm going to go up and see if I can get to the billboard. I'm going to do it this morning while the ground is still frozen.
The Ice Creek Center for the Arts and Wenatchee Valley Symphony bring arts and culture to the community through their concerts and through the support of Northwest.
A bunch of other things in that bill. There's already talk, though, of a second stimulus package brewing on Capitol Hill that with the...
Okay, here we are. I made it. I came up here so you don't have to. There is the billboard back there. It's a beautiful day. You can see all around, all down into Mattawa down there, and all the way across to the Rattlesnake Ridge. I took a pair of binoculars, and from the top I thought I could only see the big dish, but it turns out if you zoom in, you can actually see both of the dishes in downtown Mattawa. So the billboard is really big. It's even bigger than it looks from down below. Let's take a look at the wavelength of the radio waves. We know that the frequency is 11,405 kilohertz, and we know that the speed of light is 300 million meters per second. And of course, kilohertz, that's kilo 1,000 inverse seconds. And we know that C equals wavelength times frequency. So we're going to rearrange this by dividing both sides by frequency. Frequency cancels out. And we get C divided by frequency is wavelength. So now we can plug some numbers in. These are big numbers, so we're going to use scientific notation. And actually, this one is 11.405 megahertz. So we're going to say that lambda is 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 3 times 10 to the 8th meters per second, divided by 11.405 times 10 to the 6th hertz. And I'll show you how to do that on the calculator. We're using the iPhone calculator. Remember, you need to use the EE key for enter exponent. So there's the speed of light, and here is the frequency in megahertz. You get around 26 meters is the wavelength of the radio waves that are talking to the billboard from downtown Mattawa. So we've got radio waves with a wavelength of just over 26 meters coming into the billboard from the left, hitting the billboard, bouncing off, and going back off to the left toward Rattlesnake Ridge. From behind here we can see some bullet holes. Some pendeos came up here and shot at the billboard. Right up there you can see a hand crank that they can use to adjust the face of the billboard so that it's vertical or not vertical. It has to be at the right angle in that dimension too to be able to talk to Rattlesnake Ridge. So at this point my phone just stopped working. It got so cold that it decided that it was out of battery. So I headed back down the mountain, next stop downtown Mattawa. So here we are back at the antennas in downtown Mattawa. I could see from the billboard, which is just to one side of the car wash there, you can just barely see the top dish from the billboard. So that dish is right where it needs to be. Meanwhile, you cannot see Rattlesnake Ridge from here. That's why we need the billboard. So this little project has been all about reflection of electromagnetic radiation. And what we see here is that for Charter Cable Company to get its information into and out of Mattawa, its signal has to be reflected up to the Mattawa passive relay. That's what the billboard is technically called. And then it's got to bounce off the passive relay and go to the Rattlesnake Ridge antenna. It's got to be reflected 12 degrees toward the east in order to get to Rattlesnake Ridge. So all about reflection. It works the same with radio waves like these, and with microwaves, and with infrared radiation. You might have noticed that when you're using your remote at home on the TV, you can bounce the signal from the remote to the TV off of some surfaces, like glass, for example, or walls. And it works for all other kinds of electromagnetic radiation also. So next, we're going to talk about wavelength and why the holes in the billboard don't really matter, and why microwaves don't get out of a microwave oven. So stay tuned for that. That'll be the next video.